Cool.
All right. Welcome back, everybody. I hope you enjoyed your break from episode one. Today, on episode two, um, to extend from what we said about what is data science, now we're going to talk about what data science is not. And Laura, do you have any thoughts?
I mean, at the same time, it's trying to think of what data science is and what data science isn't. Data science feels like it's very interdisciplinary. So ideally, you do need to master like a large number of different skills. So like ideally, you need to have at least like a good grasp of like math, statistics, some level of programming, some level of like technical communications, and then ideally some sort of domain expertise. So all those things are overlapping when we think about data science. So maybe what isn't data science would be something that's best considered sort of in isolation. So I guess you could say like maybe like statistics isn't data science, even though it's being used in a lot of data science. A lot of data scientists will use statistics at some point. Programming itself is not data science, but data scientists will have to use some level of programming. Um,
But even with what you said about like all those components interacting together. Um, to build on what you said last time, you said data science was a means of finding insight into data and making decisions. And all the components that you just mentioned now, if they're not used for that way, I was thinking that those could be used for something else, maybe traditional engineering, for example,
yeah,
because there's programming in traditional engineering, there's statistics, there's domain knowledge, of course, but it's not being used in the same way or at the same uh, frequency uh, or severity as data science.
yeah, definitely. Like you can use programming to build any number of things that have absolutely nothing to do with data or even using data. I mean, I guess thinking about the whole idea of stats, I feel like, having statistics is and data are tied together because statistics really is inherently some sort of study of a large set of data points. But I guess it depends on, once again, like what you said about what you're using it for. So, deriving insights, but also acting on them.
So if I give you, well, I think the interesting thing about data science is that in a lot of ways it is a superpower. And if I just gave you any data, even if it was bad, and told you to just do some magic with it, could you, as a data scientist, do that by definition?
Uh, I'm going to go with no for a number of reasons, but the primary one is that in order to get good data science, you need to have like good high quality data. There's a saying, it's garbage in, garbage out, which you could probably roughly say something like, if you don't have good data, whatever insights that you have coming out of that aren't going to really be any good. So the root of being able to do good data science is like having good, accurate data. And I guess that's maybe what we should discuss next is like what constitutes like good data.
Yeah, that makes sense. But I think another question is how good does the data have to be? Should it be like completely clean and perfect, like those Kaggle data sets?
Well, I mean, the thing with like the Kaggle data sets is that they're all nice and clean, and it really doesn't represent the real world work of a data scientist. Usually when you are a data scientist, you'll get data that's by definition what we call like dirty data. It's like not clean. There's like a bunch of noise and everything. And that's sort of like normal. How clean do you have to get it? You don't have to get it perfectly clean. And in a lot of cases, you will have wished that you measured something that isn't measured in the data, and you can't really necessarily go back in time to try to measure that. So in essence, you're kind of always operating in like less than ideal circumstances. So it doesn't need to be perfect, but it can't be like utter trash. I guess it just needs to be some degree of workable. And I realize that's really, really vague because just trying to think back to like all the different use cases for data, like the quality can vary so much depending on what you're planning on doing with it and who's recording it.
So I think that's a very good point about what you said about it being vague and about quality depending on what you're doing, because it sounds like there's a lot of judgment and a lot of skill behind that. So the next question is, what is needed to become a data scientist, and is there only one way to get there?
So I guess I'll start with the second question first. Is there only one way to get there? No, there is definitely not, as testament to the fact that we both ended up in data science coming from two different post undergraduate career paths, and both of us having taken two different entries into data science. So I can definitely say there's multiple ways of getting into data science. As for what you would need to get into data science, I guess that kind of goes back to what I mentioned before about all of the interdisciplinary things that go into being a data scientist. So I guess having some level of mastery of like statistics, programming, some domain knowledge is definitely necessary. As to how much you would need, it would really depend upon the job and the company and what the company wants to do with that data. So I guess there's not really like a hard and fast rule because once again, this is still like a very fairly new field, and what every company wants to do with its data is different, as well as the quality of the data that each company has.
All right, yeah, that makes sense. But to validate somebody's knowledge, what would there be any credentials needed for that, or would there be some other validation process, or something else?
um so from a validation process, the first thing I'm thinking of is the interview process for becoming a data scientist. As we both have had lots of experience with data science interviews. It is a multi step process, and along the way will involve technical screening. So, that in and of itself also serves as a form of validation of your skills. So, usually the company will give you some sort of technical challenge. This can either be on site or on Zoom, since we're now still in pandemic world, where you will have to walk the interviewer through, or at least try to come up with a piece of code that will do whatever the challenge is. So, for example, they ask you, how do I go about creating a model for, I don't know, classifying this animal as a robot or a beaver. Um, So, you have something like that, or you could possibly have something that's a take home exam in which you will have some amount of time to do it, where the interviewer will give you some data and ask you, like, please create a model to distinguish, people who are paying us back from people who aren't paying us back, something like that. So usually that's going to be like a data challenge where they expect you to prove that you have the technical skills, whether it's knowing like your programming or your stats, to understand the problem and outline the steps that you would need to solve it. If you're maybe in like a time constrained environment, like a timed interview, you might not necessarily solve the entire problem, but at least lay out some concrete steps towards solving it. If it's a take home, ideally you would be able to solve their problem to some degree. And this once again kind of always goes with it varies because what each company wants to do with their data is different. The quality of each company's data is different. So there can be a lot of variation across companies in the technical screening. So that's maybe like one way of thinking of validation that doesn't look at credentials, because regardless of where you graduated from, or for undergraduate or grad school, or if you went through some sort of data science program, you will have to go through this level of technical screening.
Yeah, I think that's a great overview about what's being used today, and a little bit about the validation that I asked for, but I was also thinking about, are there any minimum hard credentials or degrees to say this person is or is not a data scientist?
So from a minimum degree standpoint, most job listings will at least require a bachelor's or a master's in some sort of quantitative technical discipline. What that is can vary. I've seen listings for, math, statistics, engineering, so on and so forth. And yes, there are some jobs that will require you to have a PhD in a quantitative field. Once again, this also depends on the company, what they're planning on doing. I've seen job listings that don't require a PhD, but sometimes those cases they will require a master's and maybe some number of years working a quantitative job. And I'm just trying to think as broadly as possible to encompass everything. So maybe that's kind of like a bare minimum. And other job listings will usually say that you need to have some number of years of proficiency with some sort of programming, whether it be, like Python, Java, or C. Right now, Python is like the most popular programming language for data scientists. So those are maybe like the things I think of as being maybe the most sort of mandatory requirements for job. I mean, familiarity with, like cloud computing services would be usually seen as sort of like a nice to have. It's kind of optional depending on the company. There are obviously some places that will require such knowledge as mandatory. So, it varies. But that's maybe what I'm thinking of when I'm thinking of what's like a hard requirement for most data science jobs.
So yeah, I think that's a good overview and a good point that there are different schools of thought on it, and I think we could discuss further more about the bare minimum and what that entails, because I know we'll talk about it in a later episode, but with machine learning engineering, that's kind of a cousin towards data science, and it steps off more from software development, software engineering.
Mm-hmm.
And if one looks at the job descriptions from big tech companies, the minimum education requirement for those jobs is a high school diploma.
Mm-hmm.
And with the advent of alternative ways to learn data science today, because there's not just the Insight program that you attended, there's not just master's programs like I attended, there's not just the traditional PhDs and bachelors in the quantitative disciplines, but there are boot camps, both the programming boot camps, and then both, as well as those geared towards traditional data science. But there's also another avenue, and that's being self-taught. And you did raise a lot of good points on how someone's validated in the interview process, but to get their foot in the door, I want to say that to do that, one has to be able to work and have a portfolio of different projects and show a skill set. And with um, online online courses, as well as those that are historical and those that are ones that one doesn't have to pay or get a certificate, as well as
Mhm.
the other online world of having textbooks that are online, as well as papers and maybe even videos from conferences. There's a way, well, I mean, I'm kind of questioning, and I think we've talked about this in the past, if one really, to do a job, if one really needs a bachelor's to do data science, although they would have to have the equivalent skills to somebody who's far along in that college program, maybe a third year student.
Yeah. Yeah, like I would say that like if you're able to like self-teach yourself everything that you need to learn data science, especially because a lot of the materials that are needed now can be easily accessed online, either for free or for cheap. I actually myself, before I became a data scientist, took a bunch of online courses in like data science and Python programming, either for free or for cheap. So it is definitely like possible to learn everything on your own to become a data scientist. But I guess the hard part is sort of trying to demonstrate that level of proficiency. I guess if you have graduated from like one of the more traditional disciplines, like maybe that's a way that an interviewer or a potential employer might assess your level. But if you don't have that and you're going about the self-taught way, it might be trickier to demonstrate that. And maybe that's where the idea of having like a portfolio of what you've worked on can come in, because that might be able to act as a substitute in those cases.
Yes, I agree with that general thought. And um, although we could probably have more philosophical discussions as to what education really is, maybe we could shift gears and I think talk about, maybe discuss um, the democratization of data science, because that's important as well, because there's a lot of eminent PhD holders and notable data scientists that are creating massive online courses and having something that's widely um, available. And I was kind of wondering, going forward, do you think that's going to change the paradigm or the different avenues that we discussed about both the credentials needed as well as the validation for data science skills?
Hmm. I want to say I think I've taken one of those courses, and that's the Andrew Ng Introduction to Machine Learning class. How will it change? Um, that's a good question, and I really don't think I have a good answer. Uh, I mean, it's possible that you'll definitely see more and more people applying to become data scientists who will have taken these courses, and that will be maybe their first sort of foray into data science, since it's still maybe not entirely heavily established yet at the sort of bachelor's and master's level of curriculum. So I expect to see, a lot more people going to data science whose initial interests were sparked by taking these courses. Um, I want to say that's all I can really think of on that. Most of what I've been dealing with whenever I've been in interviewing has really come from the more traditional way of assessing an applicant, where they asked one about one's coursework or if it's not your first job, like what did you do at your prior data science job?
Yeah, that's a good answer. And I mean, I had a few other thoughts, and um, with data science being rapidly evolving and based on what I experienced, I noticed that uh, getting a degree at any historic point in time, one still has to keep learning to get into data science. Because, for example, um, I finished my master's before TensorFlow had a stabilized version,
Mm-hmm.
and I didn't really learn um, how to use that or that area or that application of deep learning rather until um, after I finished school. I took Andrew Ng's uh, deep learning specialization to do that, and then I read that book by that Keras creator, which was pretty good. But my point is that um, it's not a finite thing, and um, the curriculums that are today are not going to be the same as the curriculums a couple years from now, and especially not 5 years from now.
Yes, definitely. I definitely agree with you on this. This was something that was brought up when I was interviewing at a specific company a couple years ago when I was interviewing for my first data science job. They mentioned that, oh yeah, by the way, like the tools change every couple of years. So like maybe like every 2 years, be prepared to like learn a new tool. And like I actually managed to basically, I think I probably finished my PhD before PySpark became a thing. I'll have to go look that up. But but yeah, like I will definitely say that I agree with you the point that because the field is always changing, you always have to be willing to learn new tools. And that's also a really important part of being a data scientist is sort of keeping up with the newest developments and the newest tools, both I guess from like a personal level, but also I guess on like a company level, especially if your company decides that it will adopt a new tool. And this also, I think, ties into something that was mentioned when I was at Insight Data Science doing my boot camp a few years ago, was to mention that, yeah, like right now there's just not really like a focused curriculum. And one of the trickiest things about developing such a data science curriculum is that when you're developing curriculum, you're looking at the things that are always trying to stay constant year after year. But that's so tricky in data science because the tools are always changing and new people are always releasing new packages. So that's one of the challenges that the program directors saw back at that time.
Yeah, it's an interesting story. Um,
Like, do you
yeah, I
want to
think
describe, like, a little bit more detail what your master's program in data science was like? And I know you mentioned it kind of had these boot camps like built into it, but can you elaborate?
sure. So if I recall correctly, the boot camps comprise mostly the main languages, SAS, of course, R, Python, and then more of the big data tools, for example, Hadoop, MapReduce. I think they added some other things after I left, like Spark, Watson. Um, I did sit into like a MongoDB thing that was part of my coursework as well, but at a high level in terms of classes, like there were classes in machine learning, there were classes in big data distributed computing, um, as well as the artificial intelligence with Watson. Um, and then taking a step back, um, there were classes in data mining, as well as the multivariate statistical analysis.
Mhm. Yeah, no, that's definitely cool. And definitely, at least on the bright side, they definitely had you learn a bunch of different languages, which is really nice because I know once again that still goes back to the whole like the language, even like language can change. think, what was it, at some point R was very popular for data science and now it isn't.
I actually learned Java after I graduated, and I used it a little bit when I was at IBM, not just both for setting up a bunch of drivers with what we were doing, but a little bit with the UIs and dashboards that did deliver machine learning / deep learning model via an application.
Nice, nice. I actually picked up R when I was in grad school. I think like our statistics and epidemiology classes were taught in Stata when I was a student. And I think gradually like more R programming was introduced. And I picked up R maybe halfway through my being a grad student. And that's kind of how I was introduced to sort of like programming for data science was through R. So that was my gateway thing. And I learned how to use Python when I was a postdoc and after I had already learned a bunch of R. I think I even still have that book, R for Data Science, sitting on my bookshelf. And I've not used it in a while.
Well, I'm sure there's like a lot of our viewers who would like to learn more about it.
About R for Data Science.
Yeah.
All right, at some point, maybe in a future episode, I will bust out that book and we can go through it.
All right, sounds good. I think we had a pretty good talk about data science, and next time we can talk more about the difference between data science and machine learning.
Of course, yeah. Well, stay tuned and thank you so much for listening, and we'll see you on the next episode.